You still haunt the aftershow. Emerald sky, you're burning thin. The stage is gone, but the echoes within. At the graveyard, snowbirds sleep. Pour the vodka, dark and deep. Where we burn will fade away. Nothing left to feel or say. Pour it slow. Still curls from broken ground, wax and sorrow all around. Names are gone, but ash remains. Whisper love through frozen veins. Pour it slow, pour it clean. Glue my eyes. face runs red. Words dissolve in things unsaid. We fade through smoke, through noise, through fear. And still I feel you disappear. Two ghosts in undertow, a taxi Eldorado. We lost the dream, we lost control. No need for tomorrow, tomorrow won't come at all. Only the echo, only the glow. We played escape, and now we know. We played escape again tonight. The city burned behind the light. Your pain was heavy on your spine. Your hands were trembling close to mine. Two shadows in stereo, a taxi to El Dorado. For a heartbeat, we had it all. No need for tomorrow, tomorrow won't come at all. You hum the sound of cheapo songs, where all the right feels somehow wrong. I say one. White smoke, black veins, dying slow inside this frame. You were laughing while I drowned. I breathed you in, you pulled me down. 3 dots on the tip of a needle, 3 marks in life, 3 times but later. Soft calm running through my veins. Don't sleep, don't sleep. 3 dots to connect, the rest can wait. 3 notes, 3 dreams to recreate. Don't sleep, don't sleep. Three dots on the tip of a needle. Three marks in life, three times for later. Soft calm running through my veins. Don't sleep, don't sleep. Three dots to connect, the rest can wait. Three notes, three dreams to recreate. Don't sleep, don't sleep. Pulse on fire, crowd in motion. Heartbeats crashing, slow explosion. Static light, electric skin. Let the darkness pull you in. Three dots on the tip of a needle. Three hearts collide, three souls unstable. Soft calm fading into heat. Don't sleep, don't sleep. White smoke, black flames, dying slow inside this frame. You were laughing while I drowned. I breathed you in, you pulled me down. Three dots on the tip of a needle. Three marks in life, three times for later. Soft calm running through my veins. Don't sleep, don't sleep. Three dots to connect, the rest can wait. Three notes, three dreams to recreate. Don't sleep, don't sleep. Glass in my eyes, it's not your sin. My breath disturbs the quiet within. I looked for you and found a half turn around. I'm still intact. Three dots on the tip of a needle. Three marks in life, three times for later. Soft calm running through my veins. Don't sleep, don't sleep. Three dots to connect, the rest can wait. Three
Пані та панове, шановні учасники Медsynergy, щиро вітаємо вас у серці Галичини на другій науково-практичній конференції студентів із міжнародною участю Medsynergy, організованій Європейською медичною студентською асоціацією на базі Івано-Франківського національного медичного університету.
Ladies and gentlemen, dear Medsynergy participants, we warmly welcome you to the heart of Galicia at the second scientific and practical conference of students with international participation, Medsynergy, organized by the European Medical Students Association on the basics of IVANO-FRANKIVSK National Medical University.
Medsynergy – не просто про співпрацю понад 150 активних учасників з усього світу. Це про синергію студентів та викладачів, про створення нових ідей та їх реалізацію.
Medsynergy is about the cooperation of more than 150 active participants from all over the world, about the synergy of students and teachers, about the creation of new ideas and their implementation.
Щиро раді вітати спеціально запрошених гостей. Проректора з науково-педагогічної роботи, стратегічного розвитку та інновацій.
We are very pleased to welcome specially invited guests, Vice Rector for Scientific and Pedagogical Work, Strategic Development and Innovations,
Олександра Бульбука. Також начальницю відділу освітніх та навчальних проєктів для надавання медичних послугів НСЗУ, керівницю Академії НСЗУ,
Providers of the National Health Service of Ukraine, Head of Academy of the National Health Service of Ukraine,
Євгенію Мельник. А зараз до вітального слова запрошуємо проректора з науково-педагогічної роботи, стратегічного розвитку та інновацій Івано-Франківського національного медичного університету Олександра Бульбука.
We invite the Vice Rector for the Scientific and Pedagogical Work, Strategic Development and Innovations of the Ivano-Frankivsk National Medical University, Alexander Bulbuk, to give a welcoming speech.
Мені дуже приємно, наскільки мені більше 5 університетів у нас на Івано-Франківщині, 100 людей, наших гостей. Раді вітати на Івано-Франківщині і, власне, Івано-Франківському національному медичному університеті. Передаю вітання від ректора Романа Івановича Яцишина. Він на даний момент працює активно в закордонному відрядженні і обіцяв, що в неділю він з вами побачиться. І дуже він цього хоче, і він підтримує активно. Скажу щиро, що... Добре? Бо я щось пропадаю з цього. Скажу щиро, що починаючи свою роботу давно, в 2000-х роках, один важливий момент зауважив, це те, що коли студенти самі щось творять, коли вони займаються творчістю і щось пропонують викладачу, і це можливо зреалізуватися, робота, напевно, разів 10 ефективніше. Тоді ми ще не знали про партнерство міжнародні, не знали про таке поняття, як студентоцентризм. З 2 мікрофонів ще не виступав, але дякую. І на така потужна конференція, і що організаторами і ініціаторами є студенти. Це, власне, і є студентоцентризм. Це йде мова, студентоцентризм – це не про створення, що студентам було комфортно, щоб менше задавали там, вчитися на занятті, щоб менше було кращі оцінки ставили. Це є дуже важливо, і я надзвичайно вдячний організаторам за те, що це Всім мирного дня, плідної праці і успіхів. Дякую.
Європейська медична студентська асоціація – це організація, яка об'єднує понад 10 тисяч студентів-медиків з усієї Європи, забезпечує спільний розвиток медичної освіти, а також сприяє професійному та особистому розвитку майбутніх медичних працівників через освітні програми, наукові конференції та волонтерські проєкти.
The European Medical Students Association is an organization. So EMSA is an organization that unites over 10,000 medical students from all over Europe, ensures the joint development of medical education, and also promotes the professional and personal development of future medical professionals through educational programs, scientific conferences, and volunteer projects.
А зараз слово надається голові оргкоманди Medsynergy Христині Гафійчук.
So now the floor is given to the head of Medsynergy organizing team, Христина Гафійчук.
Today we have so many participants from different universities of the Ukraine and not only from Ukraine. And I'm so happy to welcome you in IVANO-FRANKIVSK National Medical University. I hope that these 3 days will be full of synergy of medicine and science, synergy of Ukrainian students and foreign students, and synergy of innovation and practice. And welcome to Medsynergy 2025, and I hope that I will see each of you and more participants next year too. Have a nice days with Medsynergy, EMSA, and IVANO-FRANKIVSK National Medical University in IVANO-FRANKIVSK.
А зараз не можемо не згадати наших партнерів, без яких ця подія не відбулась би. І наші наукові партнери – Івано-Франківський національний медичний університет, медична навчальна онлайн-платформа «Осмозіс», Міжнародна нейроурологічна спільнота, міжнародні наукові конгреси, Медікаліс та Бімко.
We cannot fail to mention our partners without whom this event would not have taken place. Scientific partners: IVANO-FRANKIVSK National Medical University, Osmosis Online Medical Educational Platform, International Neurourological Community, Medicalis and BIMCO International Scientific Congresses.
Організаційні партнери – студентський профком Івано-Франківського національного медичного університету, осередок наукового товариства імені Шевченка в Івано-Франківському національному медичному університеті.
Organizational partners: Student Trade Union Committee of Ivano-Frankivsk National Medical University, Center of the Shevchenko Scientific Society at Ivano-Frankivsk National Medical University.
Та організаційні партнери – доставка піци на дровах «Лап'єц», кафе «Смакотерапія», вода «Карпатська джерельна», відпочинковий комплекс «Дем'янів маєток».
And organizational partners: Лап'єц, Смакотерапія Cafe, Карпатська джерельна and Дем'янів маєток.
А зараз, шановні учасники Medsynergy, розпочинаємо роботу згідно з програмою конференції, котру ви можете знайти у чаті конференції, а також на ваших бейджиках позаду.
So now, dear Medsynergy participants, we are starting work according to the conference program, which you can find in the conference chat.
Just like a few minutes, because like we're waiting for our delegates from partner university, and they are coming. And to not disrupt our lectures, just like 5 minutes of wait, and you could treat yourself with coffee breaks, like short coffee breaks, if you wish. Okay.
зараз. Ні, кажу.
Oh. Так. Ви просто їх цепаєте. Все добре, воно гасне, але він типу є. Якщо виключити, треба натиснути. Потримати. Ще більше виключити.
We played escape again tonight. The city burned behind the light. We played escape again tonight. The city burned behind the light. Your pain was heavy on your spine. Your hands were trembling close to mine. Two shadows in stereo. A taxi to El Dorado. For a heartbeat we had it all. No need for tomorrow. Tomorrow won't come at all. Won't come at all. You hum the sound of cheap old songs, where all the right feels somehow wrong. I say one more day, don't go. You just stare through the afterglow. Two lips on vertigo. A taxi to El Dorado. We spin through lights, we start to fall. No need for tomorrow. Tomorrow won't come at all. The night folds in. The glass runs red. Words dissolve in things unsaid. We fade through smoke, through noise, through fear. And still I feel you disappear.
Доброго дня. Шановні колеги, дорогі учасники. Будемо розпочати нашу програму. Будь ласка, візьміть своє пригощення і займіть ваші посадочні місця згідно куплених квиточків. Dear participants, please take your treats with yourself and take seats, so we will start in 1 minute.
Запрошуємо Євгенію Мельник, начальницю відділу освітніх та навчальних проєктів для надавачів медичних послуг НСЗУ, керівницю Академії НСЗУ.
We invite Yevgenia Melnik, head of the Department of Education and Training Projects for Healthcare Providers of the National Health Service of Ukraine, head of the National Health Service of Ukraine Academy.
Hello, everyone. I'm very happy to be here with you. I didn't prepare this lecture in English, so sorry for my English, and I will duplicate maybe some of the terms in Ukrainian so that you understand all the topics and all the terms. The topic that I want to share with you is rather difficult, the healthcare system's financing. So I'll try to explain this difficult topic like in my own words so that you all understand it. So before we talk about healthcare systems financing, I would like to address a very important term in that corresponds to this financing and to healthcare systems at all. And this term is universal health coverage. In Ukrainian it is універсальне охоплення населення медичними послугами, universal health coverage. It's a term that was introduced by the WHO. That means that all individuals receive the healthcare services they need of appropriate quality without experiencing financial difficulties. It is very important term, and it is very important definition. It may seem that it is very it's not very difficult to understand, but I would like you to pay attention to this definition, and we will try to explain some of the separate words of this definition together. For example, when we are talking about all individuals, okay, let's use this one. When we are talking about all individuals, it means that all population has access to medical services. There are countries, for example, that only working population has access to medical insurance or other medical services. For example, there are countries where only civil servants or, for example, military units have access to such services. And in such situations, we can't talk about universal health coverage, as not all population has access. In Ukraine, we tried to achieve this universal health coverage because in our laws and in our other decrees, we proclaim that all population, all citizens of Ukraine have equal access to all the services they need. When we are talking about appropriate quality, another part of this definition, when we are talking about appropriate quality, it means that there is some correspondence with medical standards, with guidelines, with evidence-based medicine. Quality of medicine is a very difficult term, and we can talk like an hour only about the quality of medicine. But now in this specific definition, I would like to stress this correspondence to medical standards and to clinical guidelines. Another part of the definition, they need. So the services they need. It means that not patients decide what services they need. It's the function of a clinician, doctor, to say that this patient needs these services, and it's not the role of patients to decide what they need, as it is sometimes in Ukraine. For example, when patients come to a doctor and say, I want this referral, please give me. So even in this definition of WHO, it is stressed that universal health coverage means that individuals receive services they need, not they want to receive, but what they need. And the last part, without experiencing financial difficulties. It is the main part of this definition because there are a lot of situations when patients suffer from financial difficulties when they need some services. And we will talk about this little more. Here. This is picture from WHO course on financing of medical services, where you can see that there are different situations of financial spending of households. And WHO says that there are two types of out-of-pocket payments. The first one is catastrophic healthcare expenditure, and the other one is expenditure that leads to poverty. These like two terms that were introduced by WHO as well. And there are a lot of analytics and like analysis that that analyze these situations when, for example, after suffering of some expenditure, after the need to get some services, the households, they go below the poverty line after this expenditure. And this situation is very critical, and such situations must be paid a lot of attention from the government, so that such situations of this expenditure that leads to poverty that don't occur anymore. This is another variant of this picture, that there are different situations of household position after some kind of healthcare expenditure. For example, there are situations that households were above the line of poverty, and after this healthcare expenditure, they go below the poverty line, and it means that this expenditure like leads to poverty. It's in Ukrainian it means витрати, що призводять до збідніння. And you may think that this catastrophic spending is something like very huge. For example, that you need to go abroad for some medical services, or you need very expensive, I don't know, cancer treatment. But the situation is that WHO thinks that catastrophic spending is only 40% of your household expenditure after like the basic, after you pay for basic needs, for food and for like for your house. And if the expenditure is more than 40% of the money left, then it is catastrophic expenditure. And in Ukraine, even several thousand hryvnias a month is catastrophic spending. And we know that, for example, to go to a hospital, for example, with some like needs, you need to spend more than several thousand of hryvnias. So a lot of Ukrainian population, a lot of a huge part of Ukrainian population suffer from this catastrophic spending. And now let's talk about this financial concept of functional concept of these healthcare financing systems. It's there are a lot of text here, but you will receive these presentations, I think. This diagram shows that there are, in this financing system, there are several functions. For example, resource allocation, pooling, and purchasing of medical services. There are also medical guarantees in this system, and all this leads to the goals that we need to achieve in order to achieve this universal health coverage. The first one is fairness in the distribution of resources. It is very important that the resources and services are distributed regardless the place of residence, the like social status of patient, and the economic, the financial possibilities of this patient. So regardless all these circumstances, patients need to receive the needed care. Another one is efficiency. It means the optimal use of funds and resources in the healthcare system. You know that all countries face the difficulties with the enough amount of resources. There is no country in the world that can finance all the needs of the population. So there is a lack of money in all countries. So this optimal use of funds and resources in healthcare system It's like a must-have for all the countries. And another goal is accountability and transparency. This means that all patients and all the transparency means that all the patients know their rights and obligations in receiving the health care services, and also that providers of healthcare services know their rights and obligations within the system. So patients know that, for example, they need to have a referral if they want to go to the hospital, and like providers know their rights and obligations as well. Also accountability, it's, for example, the situation when the national payer shows all the treatment, agreements and so on, for example, that all the system is transparent and you can see how much money spends, for example, on some hospitals and so on. And let's talk about these three functions. Let's talk about these three functions. I know that you are having a debate today about financing, about insurance, medical insurance, and so on. And you will need to know these like three functions if you want to debate like in a correct manner. So these three functions mean mobilization and collection of resources. The next one is combining risks and funds. It means also pooling. And the third one is purchase of health services. We are about when we are talking about the first fund, it means effectively raising funds to finance the healthcare system. In any country, whether it is a national payer, for example, or it is a medical insurance in this country, you need money to be gathered, to be collected. So the way the country collects money, sometimes it defines the type of medical system in this country. For example, the main types of the money resources are general taxes, special taxes, voluntary health insurance, and patients' own payments. It's out-of-pocket payments. So these are the main types of the funds that can be like put together in the country to finance healthcare systems later. There are countries that decide to pay for healthcare services from general taxes. It's like Ukraine, for example, or Great Britain. When we are talking about special taxes, it's about this medical insurance, for example, it's a special tax. But also we have voluntary health insurance. The other types are also international help, international donation. Also, it is also one of the types where we can take money, for example. What are the main goals of this resource collection? It's a mobilization of sufficient resources to advance towards universal health coverage. You cannot access this universal health coverage without enough money. So you can declare that everyone has access to all services, but if you don't have money to pay for them, then it will stay just a declaration. So you need sufficient resources for this. You also need a stable and predictable flow of funds. You know that it is very difficult to plan something when you don't know how many money you will have, for example, in next period. So it is very important for healthcare providers, for hospitals, to have this predictable flow of funds. But it is also very important for NHSU to have this predictable flow of funds, so that we know, for example, how many money, what budget we will get next year. It is very important for us as well to plan our purchasing of services. Also, transition towards reliance mainly on public revenue sources, because the experience of other countries shows that the public revenue sources are mainly predictable and sufficient when we are talking about like this funding. If we are talking about other sources, for example, out-of-pocket, international, or private, they are not enough predictable and stable. And the last one is fairness in financing. Where we have talked about this equitable distribution of the financial burden across society, so that like sick young pay for old, and like for example healthy pay for sick people. It's like this principle of distribution across society. When we are talking about this main source of income, we can divide all countries like in two main types. It's healthcare system financed by general tax. They are called national health systems. Australia, Finland, Sweden, and Great Britain. And when we are financing by special tax, we call these like health insurance systems. It's two types of systems that you will debate, I think, today. But when you have health insurance systems, there are some differences between countries as well. For example, you can have a single payer system when you have an insurance, but you have a single payer who receives all the money from insurances. But you also can have countries with many insurance payers in it. For example, with automatic choice of policyholder. For example, if you live in some district, you can pay insurance only to a separate like company. But you can also have many insurance companies, but with the right to choose the insurance company. For example, in Germany, in the United States, there are a lot of insurance companies and you can choose. So when we are talking about insurance system, there are differences between different insurance systems as well. You can have single payer, you can have a lot of payers with automatic or not automatic distribution of these insurance companies. Why we don't talk about voluntary health insurance as a main source of money? There are some examples from different countries. For example, France. In France, 90% of all population have voluntary health insurance, but it corresponds only to 13% in total health expenditure. It means that almost all population have insurances, but it doesn't make a lot of money to the health system, because these insurances are usually like additional. They are additional to the main special tax. There are other countries, for example, where voluntary health insurance is not as popular as in these countries, but there is no country where voluntary health insurance is the main source of money for a country. So we can't think that it can, for example, become a main source of money in Ukraine as well, because there are a lot of countries like which have experience in voluntary health insurance, but it doesn't bring a lot of money to the system. Another, the second function is mobilization and pooling of resources. For example, okay, we gather these resources, but what we do next? Do we put them in one single budget, or do we divide it in a lot of budgets? For example, if we have a lot of insurance companies within our country, then we will have a lot of budgets, and the distribution of money between these budgets, it doesn't help to distribute money fairly within the country. When we ask how much money is needed to form a budget, how many you can say, the more the better, okay, but according to recommendations, international recommendations, you need at least 5% of budget of the GDP to be spent on healthcare. How many percent do we have in Ukraine? Do you know? How many how many percents of GDP do we spend on healthcare services in Ukraine? It's less, of course, less. The state budget in 2025 was $220 billion, and it's around 2 and 6% of GDP, of projected GDP. It's state financing. It's not only for health benefit, medical guarantees program, but also all healthcare budget. But it's only 26% of GDP. If we add here out-of-pocket payments that are around 2 and 4% in Ukraine, it's almost the same that countries spend on services, the same people pay themselves. So you will get these 5%. The 5% needed you will get, but together with out-of-pocket payments. So it's one of the problems why we have out-of-pocket payments in Ukraine, because we don't have sufficient money to spend on healthcare services. But if, for example, next year we have 5% of GDP, will we still have out-of-pocket payments? Yes, of course, because it's not enough just to put more money in the system to change the system. We need a lot of other things to be changed in order to lower these out-of-pocket payments. So why this function of pooling of funds is so important? Because it corresponds to this equal distribution of money. If we have one, this large pool of funds, then we can distribute from healthy to sick people, from rich to poor people, when we have this one large pool of money. There is a question from WHO, for example, which of the charts shows the best situation of pooling of money. Pool spend it equally on the population. The pool spent equally according to the needs, or pool spent equally according to the payments. So which situation is the best? Yes, according to needs, it's like the best situation, and this is the aim of this pooling of money, that they are spent according to needs, not equally among all the population, and not according to the money every individual paid. Another question: what is the best? What is the best amount of money, the size of this budget? Should it be, for example, a lot of budgets but small, or should it be one but big budget? How do you think? One and big? You think that's a lot of small? Another question about combining of risks. Should one pool consist of similar risks? For example, let's divide all population, for example, all, pregnant women here, or disabled people here. Should we combine risks, or should there be diverse risks in one pool? But why do you then think that a lot of small budgets Mhm, mhm. Mhm. Okay. And the participation, should it be voluntary or should it not be voluntary? The participation in these pools, in insurances? Yes. And the answer is the bigger the pool, the better. You should also combine different risks, and the participation should be obligatory. It's like the ideas of WHO. So when we are talking about these pools, the green one is pools with different risks, and here are divided different pools. And I think that you can understand that, for example, if something bad happens, for example, with a pool of, I don't know, older people or, for example, disabled people, they won't have enough money to cover all the expenses, for example, and the pool with healthy young people like will have money, but other pools will suffer from the lack of money. And this is also the idea why one pool is better. It's not only the equal distribution of risks, but also the possibility, for example, also we are talking about surgery and, for example, primary healthcare. We have this, we divide this within, for example, medical guarantees program as well. But if something happens in, I don't know, for example, surgery part, then we can distribute money from other parts to this, and it can be also only possible when there is one huge pool. But I will return to this. Here is the example from France, but from Germany, but I also saw such examples in other countries about the distribution of money and distribution of risks. For example, you can see that 5% of population, they correspond to almost 50% of all expenses in a population. So it's like 5% of the most disabled, sick people of the country. So if you distribute these risks, like divide them into parts, then you can understand that this is the first one to be empty, for example, in a certain period of time. In Ukraine, before 2018, we had a lot of pools. We have, I think, almost 800 pools. These were the, I don't know, subventia, subventia, it's these small budgets that every territory community have their own this subventia. The all state budget was divided in this small subventia to every region. And for example, if there were some, I don't know, disaster in a region or something like that, then this were all the expenses, and there were like problems between the distribution of money between these separate budgets. But when the National Health Service was introduced in 2018, all these subventions, all these budgets, they were combined in one single budget of medical guarantee program. So this is a single budget, single pool. It's not all the healthcare expenditure in the country, because there are other budgets, for example, like for example, for services abroad, for some purchasing of drugs and so on. But it's like the main part of all healthcare budget in Ukraine. It's the medical guarantee program. And it's a single budget within which you can distribute money to those patients and to those and to those spheres that need this money. In Ukraine, we have like this um, приклад, example, yes. In Ukraine, we have this example of this single budget and single pool of money. And this is the second function. And the third function is the distribution of resources, the resource allocation towards the care providers for the benefit of patients. And all countries move from passive purchases to strategic procurement. So it's like the idea that healthcare funds must be allocated within the strategic procurement. What does this mean? It means a strategic procurement of services means that we can answer three main questions. What do we pay for? From whom do we purchase services, and how much we pay for these services? If you can answer these three questions, then your purchasing is strategic. For example, what do we pay for? Should we cover all services, or should we like have a list of services we pay for? In Ukraine, we have these packages of medical services, and it's the amount of services that are paid for within the medical guarantees program. From whom do we purchase services? Should we pay to all the providers, or should we pay only to the providers that corresponds with some requirements? For example, they have enough staff, they have enough equipment, and so on. So if you have some requirements for the providers, then you can say that I don't purchase from all the providers, but only from several providers that meet the requirements. And the third question, how and how much do we pay? So should I pay for all services like equally, or should I use different types of payment for each service? This also corresponds to strategic purchasement. I think that you might see this universal health coverage cube. It's a very popular concept that you don't have enough money to cover all the needs. So you need to decide who can use this guarantee package, how many services we can pay, is there any co-payments, or so on. How do you think? Do we have a co-payment within medical guarantees program in Ukraine now? Yes, we have the affordable medicine program, програма «Доступні ліки». It's part of medical guarantees program, and you have co-payment for these drugs within this program. So we really have this instrument, but we don't use it now within medical services, because our modeling and our analysis showed that this won't bring more money to the system, but it will lead to less access to services for a lot of people. So it's very important to make this modeling and investigation before introducing such thing as, for example, co-payment. Strategic purchases, they are also important because you can analyze what is the need for services. Are the services effective? Are they cost effective? What are the barriers to access these services? And do providers correspond with the requirements? So it's a very important instrument in order to achieve this universal health coverage. And strategic purchasing is also one of the functions of the National Health Service, to decide from whom to purchase services, what services to buy, and how to pay. When we are talking about the payment method, you might know that we have different types of tariffs in Ukraine. to pay for health services within medical guarantees program. There are 5 main types of tariffs, and it's not the Ukrainian idea. It's like internationally well-known types of tariffs. It's capitation rate, the rate per treated, it's diagnostic-related groups treatment, medical service rate, it's the rate to pay for each service, global rate, and performance-based rate. Ставка за результатами виконання умов договорів, it's like performance rate. Performance rate. And a lot of, we have different packages within this medical guarantee program, and each package has its own type of tariff. And we use these tariffs also to change the provider's attitude and to service delivery. For example, if we pay for each service, we will get a lot of services. If we pay for each patient, then we will have a lot of patients. It's like, it's the golden rule of financing. So you need to understand if you services, then you should be ready to get a lot of these services. In which like packages we use these tariffs. In mammography and these endoscopy services. And we specifically within these packages, because we want to the number of services to pay for each service, for example, for ambulatory consultations and laboratory diagnostics, because we will have like millions of these services a day. When we are talking about inpatient care, about hospitalization, like the golden standard is to use diagnostic-related groups payment. I won't now like a lot about these tariffs, but you need to understand this. All these tariffs have their pros and contras, and you need the use of these tariffs itself, it changes providers' behavior. And to sum up, I talked about 3 these functions: collecting resources, pooling, and strategic purchasing. And when you're going to debate today, you need to understand that regardless it's a country with single payer, national single payer, or it's a country with health insurance, the difference sometimes is only in collecting resources. You take special taxes. All this, regardless where you take money, you can put them in single pool, big pool for all the country, or you can put them in different pools. So you can like have different variations in each of these parts. So it's not that if you decide to to move to medical insurance in Ukraine, then there is only one way. No, there are always a lot of ways how you can change the system. When we are talking about purchasing, all countries try to meet this strategic purchasing. But when we are talking about the first 2 functions, there are different variations. And when we are talking about the systems, they are called Bismarck systems of medical insurance, it doesn't mean that patients are more insured than in countries where there is no insurance, but where they have national systems, for example, Great Britain. So it doesn't mean that medical insurance introduced in the country automatically gives people all insurances and they have enough money, because there are the questions where they get this money. So you need to understand like these three functions, when you decide what kind of financial system you want to build, for example, in Ukraine. On the NHSU Academy platform, we have a course dedicated to this question, and some of this there is like famous WHO course on financing health care, and this year it was translated into Ukrainian, but you can also find it in English on WHO websites. But you can now take this course in Ukrainian on NHSU Academy. Interested in these all topics, this is a wonderful course with different examples from countries all over the world, how they move to universal health coverage and how they change their systems in order to achieve this universal health from all over the world. Different publications about health and in other countries, so you find these publications on WHO website if you want to know better like about this Okay, I'm done. Thank you. Maybe there are some questions. I'm ready to answer. Yes.
When you said that there are some individuals that need a treatment and there are others who want the treatment, I want to know what is the borderline, like how do we differentiate who are in a necessity and who are not?
No, well, I think that the physician is the one who can draw this line between the need and the want. Different like system of standardization of medical care, protocols or standards or guidelines, so that this clinician can use some evidence-based for his decision, but it must always be the decision of the physician.
So there are no universal patterns. It's depend on physicians.
Well, each case is you cannot use any model or something to answer the question, even within a country.
Thank you.
Do we have more questions?
Дуже дякую за таку неймовірну презентацію про фінансування системи охорони здоров'я зараз, тому що для нас, як для студентів, молодих лікарів, я переконана, це доволі важливий момент розуміння того, що ми можемо призначати нашим пацієнтам, як формуються глобальні бюджети і в такому плані. Але от про збір коштів, і один з пунктів, власне, є податки. Я вже як молодий лікар-інтерн, мені це цікаво, тому що ми отримуємо заробітну платню, і в нас, на жаль, зараз мінімальна заробітна платня теж не є досить висока загально по цілій Україні. Чи можемо говорити про те, що в майбутньому, близькому майбутньому ми очікуємо на збільшення податків саме для перекриття таких катастрофічних витрат для системи охорони здоров'я?
Це не просте питання. Я можу відповісти українською нарешті. Дякую. Це не просте питання, оскільки, як я відповіла в своїй доповіді, не завжди питання у кількості грошей, а ще у тому, як ми їх збираємо, розподіляємо. Ви могли чути про те, що зараз така основна розмова йде про ефективне використання коштів, тобто спрямовувати саме туди, де потрібно, і якби там не утримувати заклади, а там, щоб гроші рухали за пацієнтом. Це вся ідея про те, що не тільки кількість важлива, але і ефективний розподіл. Але якщо ми говоримо про кількість, якщо ми говоримо саме про суму грошей, знову ж таки ми повертаємось до того. Якщо ми говоримо про гроші, Про обсяг грошей ми знову ж таки повертаємося до того, звідки вони беруться. Тобто, або вони можуть зараз в Україні гроші беруться від міжнародних партнерів. Тобто, я думаю, що це не секрет, що зараз у нас охорона здоров'я повністю фінансується за гроші партнерів. Ну тобто, тут жалітися і щось дуже маневрувати у нас немає можливостей. Але навіть коли ми там починали реформу, або так як ми плануємо далі рухатися, приймалося рішення: ми запроваджуємо окремий податок, чи ми рухаємося з з загального пулу податків і загальних податків. І коли було проаналізовано рівень тіньової економіки в Україні, скільки людей будуть платити ці податки, і ви теж маєте розуміти, що в країнах, які фінансуються за рахунок спеціального податку, все рівно дофінансовуються ті, хто не можуть платити цей податок, і ті гроші, які не вистачають, все рівно дофінансовуються загального бюджету. Ну, тобто, чисто країн, які живуть тільки на спеціальному податку, таких теж немає. І от ми все рівно дофінансовуємо з державного бюджету. І давайте уявимо ситуацію, що у нас є окремий податок на охорону здоров'я, який сплачують там всі працюючі, і гроші йдуть тим, хто потребує в спеціальному фонді. Я вам скажу, що в Україні таке вже є. Це пенсійний фонд. Так працює пенсійний фонд. Пенсії у нас великі? Ні. Їх вистачає грошей в пенсійному фонді? Ні. Ну, то з медициною буде ще гірше. Коли були проаналізовані всі бюджетні надходження і коли були проаналізовані якби всі моделі і обсяги, було зрозуміло, що єдине місце, де в принципі хоча б можна брати якісь гроші на медицину, це пул загальних податків, які платять все-таки всі, бо це і акцизи, і там ПДВ, і все. Інше питання – розмір цих фінансувань. Рекомендовано 5%, в Україні 2,6%. В найкращі роки було 3,1%. Тобто, ну це все рівно не ті обіцяні відсотки, які платять. В є країнах Європи, там це, не знаю, не менше 7-8%. Там в Америці, якщо не помиляюся, здається, 12-14%. Ну це колосальні гроші, які Україна не може собі дозволити. Коли це зміниться, і обсяг, і їх раціональне використання, ну, про це зараз важко говорити, але все рівно розуміння того, що звідки ці гроші беруться і як вони далі розподіляються, воно вже трошки так якби, ну, вже дозволяє не просто говорити грошей мало, дайте грошей. Ви вже тепер повинні розуміти, що не все так просто, я кажу, не все так однозначно, що якби для того, щоб гроші от в цьому пулі з'явилися в бюджеті, вони мають звідкись прийти. Звідки вони можуть прийти в Україні, наприклад, зараз. І там співфінансування не врятує цю ситуацію, як показують дослідження, і на це там теж є окремі виступи теми. І медичне страхування, ну, ви це сьогодні самі вирішите, але якби якісь певні інструменти, я сподіваюся, вам дала, для того, щоб ви подискутували, чи варто нам запроваджувати медичне страхування, наприклад, і якщо так, то яке, наприклад, яка із моделей, яка теж сьогодні була представлена.
Тоді в мене буде ще одне запитання, бо, власне, я проходжу інтернатуру в гематологічному відділенні, де з нами працюють так само лікарі-онкологи, і, власне, ширяться чутки серед лікарів-онкологів, що буде скорочення глобального бюджету, власне, на пакети онкологічні. І чи це справді ми очікуємо того, що онкологічні пакети будуть зменшувати фінансування, чи про це рано говорити зараз?
Ну, це якраз те, про що у нас була дискусія, в те, що всередині програми медичних гарантій теж є окремі напрямки, і там дійсно є якесь певне фінансування, яке розділене. Я знаю, що минулі роки навпаки було зростання бюджету на онкологічну допомогу. Я, на жаль, не знаю точного розподілу на наступний рік. Там десь якби лунали якісь публікації в Фейсбуці очікуваного бюджету. Він теж буде зростати. Кожен рік бюджет програми медичних гарантій зростає, але я не можу, на жаль, сказати конкретно про онкологію. Я знаю, що це один із пріоритетів якби діяльності уряду, пріоритетних напрямків охорони здоров'я, тому я думаю, що там не повинно було бути скорочення. Там, скоріше всього, будуть навіть якісь нові напрямки додаватися. Але я не можу чітко сказати, чи буде менше грошей в наступному році.
Це залежить від чуток лікарів-онкологів. Чи є ще в когось запитання? Якщо немає запитань, то дуже вам дякуємо, Євгеній Мельник, що ви сьогодні долучилися до нашої конференції. Сертифікати від нас і вашої команди. Дуже вдячні, адже вважаємо, що фінансування – це те, що стосується кожного, і студента в тому числі, тому що ми будемо рано чи пізно працювати в цій системі і отримувати зарплату за цієї ж системи теж.
Я вам всім дякую. Можливо, я не настільки класно все розказала, але в онлайн-курсі там просто все супер. Тому я дуже рекомендую вас його пройти, і там точно у вас тоді питання залишиться.
І
Дякую.
так, ви отримаєте посилання до цієї презентації, тобто всі QR-коди і джерела ви зможете знайти в чаті WhatsApp. Дуже дякуємо вам. Давайте оплесками підтримуємо нашу лектору, я перепрошую.
Ще раз вдячні за таку неймовірну доповідь, а також звертаємо вашу увагу на те, що після проведення воркшопів та після обіду у наших учасників буде можливість взяти участь у дебатах стосовно ролі НСЗУ в Україні, де пані Євгенія теж буде брати участь, і також із завідувачкою кафедри громадського здоров'я Ориною Децик.
So again, we are extremely grateful for an incredible report. Please note that after lunch, our participants will have the opportunity to participate in a debate on the topic of the National Health Service of Ukraine, together with Ms. Yevgenia Melnik and the head of the Department of Public Health, Orina Decek.
А зараз вітаємо нашого наступного спікера з Лунського університету, Швеція, Філіп Калдіс, професора, віце-координатора Центру цукрового діабету Лунського університету з темою «Метаболічні зміни при гепатоцелюлярній карциномі» у зв'язку з усіма відомими обставинами. На жаль, цьогоріч доповідь нашого партнера буде онлайн, тому щиро вдячні і запрошуємо вас до уваги.
So we welcome our next speaker from Lund University, Sweden, Philip Kaldis, professor, vice coordinator of Diabetes Center of Lund University with the topic Metabolic Changes in Hepatocellular Carcinoma. Due to all known circumstances, unfortunately, this year report of our partners will be online. Dear Professor Philip Kaldis, you can start your presentation. Switch on your microphone because we don't hear you.
Can you hear me now?
Yes.
Okay, good. And you can see the presentation.
Not yet, but it downloads.
Okay. Let me know when it's there.
We can only see the white screen.
Hmm. Yes, that I can see. I'll try again. Hmm.
Maybe you can send your presentation to us and we will present your presentation on the screen. So just send it maybe.
I can try to do that. Yeah, but the problem is the presentation is too large for me to send by email. Now somebody is calling me.
So dear participants, while we have some problems with connection, you can help yourself to the cookies and coffee and tea. So have a little break and help yourself to some snacks.
I'm sorry for this. I don't know why it's not working.
Okay, Professor, could you log out the conference and then trying to enter again? Maybe it will help.
Yes, okay,
Okay,
good.
let's try. Ага, я знаю. Так, так. Франківська зла. Could you hear me, Professor?
Yes.
Yes,
I can,
super.
but I'm trying to share it with you, and it doesn't seem to be working.
Could you try to send this presentation via email or WhatsApp, for example? Maybe it will work.
Um, a new window.
No, now we couldn't see you either presentation, just like
Yeah,
whiteboard.
trying with another computer.
Dear Professor, could you please check your email? And we have sent you a phone number. If it is possible, could you please send to any messenger the presentation so we could upload and start it here from our laptop?
Yeah, the problem is the presentation is very large, and
How large is that?
100 megabytes.
It can work actually for messenger.
One second, I will try it now on a different computer, and then we'll see if it works. I'm just entering the numbers. Lina, it's the same again. The phone. Lina. I'm just trying to connect with it from a different computer. So with my laptop. Okay, can you hear me? Okay.
Super.
Yes, so now I'm trying to share.
Yes, super. We could see the presentation. Thank you.
Okay.
Okay, dear participants, we're
Great.
sorry for the technical problem that we have, but we are ready to start.
Yes, so
presentation.
I apologize for these problems,
No, it's absolutely fine.
and I'm happy to talk to you about our work, which deals with the mechanisms of obesity-induced fatty liver disease.
Could you wait?
And
Sorry for
also-
interrupt you. Could like wait 1 minute so we will gather people again to the hall.
Sure.
Okay.
No problem. Yes.
Dear Medsynergy participant, please take your seats and we are ready to listen wonderful University. So take your seats and we are ready to start. Yahoo! So, Professor, it's your floor.
Okay, great. So, good. So let's get started. So overall in the world, you can see that the rates of obesity is increasing. Although the level differs in each country, it's still increasing almost everywhere. And so one of the major questions, of course, is if obesity is really a disease or just a state of our body and of our metabolism. But if you believe companies like Novo Nordisk, they want you to believe it's a disease because they want their products to reduce obesity to be covered by insurance companies. But in general, it's an important question. And of course, different people have different opinions. But let me start to give you a little bit of background because the liver is not only a fascinating organ, but it's also what we study the most. And the reason is it's the largest organ in our body. It's the metabolic center. It is very important for detoxification, for bile production. It's heavily involved both in lipid metabolism and glucose metabolism. And in terms of glucose, it's one of our largest storage of glucose, which will be stored in the form of glycogen and then can mobilize back again. And this is very different from other tissues, for example, our brain, who cannot store any glucose at all. The cells in the liver, specifically the hepatocytes, which make up 75–80% of the cells, are mostly quiescent. They rarely divide. They're also a little bit different in that they can be polyploid, which is unusual for fully differentiated cells. And on top of that, the liver has an amazing regenerative capacity. So you can cut off, in humans, for example, half of the liver, and the liver will just grow back. Now, the incidence of fatty liver disease, which is a result not just of obesity, but also other factors, has now reached roughly 30% of the world population. That's a very large number, and this will have consequences in the future. And the reason why it will have consequences is that when we look at a healthy liver, the first step is what we call a fatty liver, or the exact term is MASLD, metabolically associated steatotic liver disease. In this stage, which is fully reversible, you get lipid droplets deposition in the parenchyma of the liver. And then eventually you also get inflammation, and then it's called steatohepatitis or MASH. In that whole process, there's also fibrosis involved. And when the fibrosis is really, really bad, we call it cirrhosis. And out of that, you can develop hepatocellular carcinoma, which is the most common type of liver cancer. So as I mentioned, the early stages of the liver diseases are reversible, but the late ones are not. And so one of the central themes in our work is to catch fatty liver disease before it becomes reversible. And as you can see on the right, we have projects along the axis of fatty liver disease, early stages, fibrosis stage, and then also in terms of cancer. When we do our work, we often start with like a screening where we use transcriptomics, metabolomics, and lipidomics to understand which are the most important pathways that are deregulated. Once we have this data and we analyze the data, then we go back into either human samples or mouse samples to do validation experiments. For example, we silence genes, we look in the mouse, we do drug treatments, we look at glucose metabolism, we look at different tissues, we look at biochemistry, and so on. And this gives us a very comprehensive view of the disease. Now, one thing that I wanted to mention is that, of course, we're very interested in the liver, but the liver is not there in isolation. In our body, the liver interacts with many different other tissues. So, for example, with the pancreatic islets, where the beta cells produce the insulin, they also interacts with the adipose tissue because it's very important in terms of lipid metabolism. It also interacts with muscle, with the brain, and with the heart. And this kind of what we call inter-organ crosstalk is actually very important. And it's especially important for complex diseases. So just to give you an idea, what happens with glucose and lipid metabolism in the liver is, what this actually should show here is how connected it is. So we cannot study glucose metabolism alone without also looking at lipid metabolism and vice versa. And you can see here on the left, glucose, I can make a laser pointer, I think. Yeah, so glucose here is taken up, it comes from the intestine and then converted into acetyl-CoA. And acetyl-CoA actually is a building block of lipid molecules. So it's very, very connected with each other. So the main goal of our studies is to investigate the metabolic remodeling during the development of liver diseases. We also would like to see if we can reprogram metabolisms to prevent liver diseases. We also wonder if remodeled metabolism affects the transcriptome, or does it start with the transcriptome that then affects metabolism? As I mentioned, we're very interested how liver metabolites affect other organs, so in the inter-organ crosstalk. And finally, can we use drugs and inhibitors targeting metabolism for the treatment of liver diseases? So I will start to tell you a story about human samples from a human cohort from very obese people. So we had 33 subjects that were obese but did not have fatty liver disease. And then we had 76 people that had MASLD. And from each of these, we had liver samples and we had also plasma samples. And we did transcriptomics of the liver samples as well as metabolomics of both liver samples and plasma samples. And as you can see here, we identified more than 1,000 metabolites, and about 60% of them were lipids. And it was quite similar in the plasma. And there is some overlap between the liver and the plasma, but it was not complete, of course. And here I just want to show you, without going into the details, that these individuals had a BMI above 40, which is very obese. When we then look at the untargeted metabolomics, a lot of lipids come up. So here on top, we have triacylglycerides, and those associate mostly positive with steatosis, inflammation, ballooning fibrosis, and the NAS score. We also have others, diacylglyceride, again, associating positively with all the clinical parameters. And diacylglycerides are precursors of the triacylglycerides. But then we have phosphatidylcholines, another lipid type, which is negatively associated with steatosis, inflammation, ballooning, fibrosis, and NAS score, and so on. But on top of the lipids, we can also identify amino acids, carbohydrates, and nucleosides. When we look more carefully at all the different species, lipid species here, again, you see this upregulation of the triacylglycerides and diacylglycerides, but then we see also downregulation of phosphatidylcholine, sphingomyelins, and other lipid species. So one has to look at them very, very carefully to understand what's going on. More importantly, even if we look at just one type of lipid, like the triacylglycerides here, it depends how long they are. So how long are their chains and how many double bonds they have. Because if they're shorter and have fewer double bonds, then they're positively associated with steatosis. But if they're longer with more double bonds, then they're negatively associated. So in essence, we have to look at each of these lipid species from the class of triacylglycerides to understand what's going on. As I mentioned, we did transcriptomics, so RNA sequencing on these samples. And when we looked at those samples from patients that only have steatosis but no fibrosis, we can see there are differences. So there's very limited overlap between fibrosis and steatosis. Interestingly enough, also for fibrosis, we see more downregulated genes than upregulated genes, whereas in steatosis it's mostly upregulated and much fewer downregulated. But then also when we look at the pathways, they're quite different in steatosis. It's mostly immune response, carbohydrate, metabolic processes, apoptosis, protein phosphorylation, and proteolysis, and a little bit of lipid metabolism there. In fibrosis, instead, it's much more about signals transductions, for example, toll-like receptor pathway, Wnt signaling, and then especially extracellular matrix organization. Whereas on the downregulated gene, we see lipid metabolism and then also a lot of mitochondrial genes functions that are downregulated. So what we then can do is we can combine the RNA sequencing and the metabolomics. So now in those boxes here, this is metabolomics data, whereas in the circles, these are transcriptomic data. So for example, this is diacylglyceride and triacylglycerides. They are in the convertible, and we have seen here increases in red, and then the enzymes that convert them are also increased. So we have a good interaction between our metabolites and also the transcriptomic regulation. But then phosphatidylcholine, phosphatidylethanolamine, they are rather downregulated on metabolite level. And then we have genes here, for example, this GMT1, which is quite interesting. It's involved in one-carbon metabolism that is downregulated. And it's actually involved in the excessive release of retinol, which is vitamin A, after activation of hepatic stellate cells. So now, when we look at the different pathways, on top here is the metabolism pathway, and down here are others. So, for example, mitochondrial pathways. And compare steatosis to fibrosis, we saw a clear difference that in steatosis, these are rather positively associated, whereas in fibrosis, it's negatively associated, which indicates that the nature of steatosis and fibrosis is quite different. And when we do a meta-analysis, we find actually steatosis is mostly driven by metabolism, whereas fibrosis is much more driven by transcription. So if you want to treat the steatotic liver versus the fibrotic liver, you have to have very different approaches. One important pathway is the TGF-beta pathway, which is very well known. And so we see this here. and this interacts with Wnt signaling and beta-catenin signaling, as well as extracellular matrix cross-linking deposition. But then we see also other pathways like MAP kinase, the GTPase signaling, PI kinase, Notch signaling, NF-kappa B, and so on, that are very important. And then transcription factor like PPRs and FXR. So we wanted to know if TGF-beta was really activated in our samples, and so we looked at those at the different stages of fibrosis. So 0 means these are samples or individuals without any fibrosis. They have steatosis but not fibrosis. Then stage 1 fibrosis is quite little, and 2 and 3 is much higher. The highest is actually 4, which we didn't have in our cohort. But for example, TGF-beta 1 increases as fibrosis increases. And here all these genes are involved in TGF-beta signaling. These are, in the middle, are SMAD pathway genes, and also down here. And they all increase as fibrosis increases. So it's pretty clear that the TGF-beta signal pathway is activated. Now we then wanted to know what are the most important pathways that distinguish steatosis versus fibrosis. And what we find is that the top pathways are actually GTPase signaling and GTPase activity. Now GTPases are small molecules that are activated by GTP, and they convert GTP into GDP. And they have a lot of different functions, but to be honest, we didn't know a lot about them. So we wanted to test this in a completely different system. So we collaborated with Volker on patient-derived, what we called liver spheroids. So he takes these samples from patients and makes spheroids, so three-dimensional cell culture, which you can see up here. And they grow very well, and they maintain the identity like in the liver. And then we did RNA sequencing from samples that came from patients that had MASH, so steatohepatitis versus control. And we can see that many of the GTPases are also upregulated in this system. And when we look much more carefully, here we have control liver, MASH livers, and then MASH livers that were treated with elafibranor, which is a PPR alpha delta agonist. And you can see in many cases, there's an increase in gene expression in MASH, and then it decreases again when we treat with elafibranor. And this is true for GTPases, GAPs, and GEFs. GAPs and GEFs are those subunits of GTPases that either convert GTP into GDP or the other way around. Then furthermore, we also treated these with either with TGF-beta, shown in purple, or an inhibitor of TGF-beta activity, which is shown in orange. And you can see TGF-beta itself is actually increased when you treat them with TGF-beta. So this is recombinant protein of TGF-beta. And if you treat them with the inhibitor, it decreases again. And this is also true for GTPases, for example, like RAF1 or DOC2. So it seems like that TGF-beta is driving the expression of GTPases. To understand better what these GTPases are doing, we did a protein-protein interaction network analysis. So we took all of the GTPases, which are about 350 proteins, and we looked with what kind of genes, other proteins are they interacting with? And we found about 5,000 proteins. And of those 5,000 protein, 500 of them were involved in fibrosis. And these are shown here. And so red means that it's upregulated and blue means it's downregulated. So you can see here R3 is a central hub of this. This is a GTPase, but also the GTPase RAC1 and RAC2 can be quite important. So then we wanted to see something else, because I mentioned to you that the liver contains mostly hepatocytes, but there are also hepatic stellate cells, and they make up only about 4 to 8% of the liver cells. But they're very important because they get activated by TGF-beta, and they are the cells that are thought to actually produce collagen, which then induces fibrosis. So we took hepatic stellate cells, and they called LX2, and we treated them either with a RAC1 inhibitor or a CDC42 inhibitor. So these are GTPases. And when we do this, there's less collagen secreted from these cells. So that means there would be also less fibrosis. So to some degree, that indicates that the activity of GTPases is required for collagen secretion. Even when we look at the expression, the gene expression of two collagen genes, collagen 1A1 and collagen 1A2, you can see there's a decrease in gene expression when we treat them with the GTPase inhibitor. So this is our model. So we think that when the liver gets stressed, TGF-beta is produced by the hepatic stellate cells, but also by Kupffer cells, and this then affects, and Kupffer cells are the resident macrophages in the liver. And this then affects all cell types, including the hepatocytes, and leads to an expression and an increased expression and activity of GTPases, which then leads to the collagen production and to the fibrogenic effects. So our working hypothesis is that excess lipids, as you find in obese individuals, leads to activation of TGF-beta as well as other genes, for example, TORC1. And then TGF-beta induces GTPases in hepatocytes, but it also will activate hepatic stellate cells, which then also activates GTPases, and that then leads to fibrosis. I mentioned earlier the loss of retinol is a well-known issue in fatty liver disease, and retinol is vitamin A, and actually the hepatic stellate cells are the cells that store and produce all of the vitamin A in our body. So this is actually very important, and this combination of loss of vitamin A and the progress of fibrosis, that is what we're trying to prevent. So now I'm going to switch topic completely, and I'm going to talk to you about liver cancer. And I've showed you this before. So you go from the healthy liver to a fatty liver, mast cell D, then steatohepatitis, MASH, you get to fibrosis, eventually to hepatocellular carcinoma, the most common liver cancer. And what has been known before is that obese individuals are more prone to develop HCC, but the molecular mechanism, how this works, is not known. And so this project deals with how can we understand how this works. And so we do this in the mouse, and generally there are different models to study HCC in the mouse. So we can use knockout or transgenic mice to induce HCC, but this takes a long time. So these tumors develop over about 12 to 18 months. We can also treat mice with carcinogens like DEN, for example, And that takes about 8 to 12 months until they develop liver tumors. Now, we have been using a method called hydrodynamic tail vein injection, and I will explain this a little bit more in a second. And we can get liver tumors in the mice in about 10 to 14 weeks. But now we're working on improving this method with the hope that we can have tumors in about 3 to 4 weeks, which really cuts down on the time it takes to validate a gene. So here's the principle on the right side here. So we inject these mice through the tail vein with a relatively large volume. So it's about 10% of the body weight. So roughly 2 ml to 2.5 ml. And we do this very quickly, so in less than 10 seconds. And this leads to high pressure through the portal vein on the liver, and you get these small little microfractures in the liver, which then takes up DNA. And this has been known since the 1960s. But the problem is the expression, if you deliver DNA to the liver, is very transient, so just for a short amount of time. And we wanted to have it more for longer periods of time. And so we're using the Sleepy Beauty transposon system, which is an enzyme called transposase. And this enzyme recognizes these sequences that we flank the gene of our interest with. And so when we do this gene here will be integrated into the genome and is expressed long term. And so we inject plasmids that will silence p53, which is a tumor suppressor, and we also inject activated RAS. And so that leads to tumors. And if we use so-called chow diet, which is normal diet here, shown here, you can see these tumors after about 12 months. So usually there will be 1, 2, maybe 3 tumors, not more than that. Now, in our case, what we do is after a week, after injection, we give the mice high-fat diet. And when you do that, you can see that we have many more tumors, which is quantified here. So this is recapitulating what you see actually in obese individuals. And so we have a system where we can test that. Alternatively, we can use genetically modified mice. These are OB mice. They have a mutation in the leptin receptor. And even on CHO diets, they are very, very large. They are anywhere between 40 and 60 grams per mouse. And we also have done these experiments there, and we see that there's also an increase in the number of tumors in these mice. When we then do sectioning of liver samples that are either from mice that were treated fed with control diet, so chow diet, or high-fat diet, and then we stain for lipids, you can see there's much more lipids here. And we can do this under a normal microscope or in the fluorescence microscope. You can see the same. But interestingly enough, when we look at the section where there's a tumor on this side here, there seems to be less lipids than over here. We can also use biochemical tests for non-esterite fatty acids, NEFAs, or for triacylglycerides. And in both cases, actually, in the tumors, we find that they are decreased. So now, how are we going to study this? So we're going to do RNA sequencing of these samples. We're also going to do metabolomics, and we will determine the pathways that drive tumor growth as a result of the high-fat diet. And then we would like to validate this either in vitro and in vivo. So this is the workflow. So we take liver samples and plasma samples. We do both transcriptomics and metabolomics, and then analyze the data. And one of the pathways that we find is interesting is the cholesterol synthesis pathway. And so the data that you see here is a little bit complicated because actually in our high-fat diet, we also have very high levels of cholesterol, which in general is known that if you take up cholesterol when you eat it, then the endogenous cholesterol synthesis is decreased. But it's actually less decreased in animals that have tumors compared to control animals. And so we think this is quite interesting. And also, we think it's not dependent on the total cholesterol because we don't see any changes there. We think it's those intermediates that could be quite interesting, and that's what we're studying now. The other pathway that we have identified, which is interesting, is the serine metabolism pathway. So it starts down here with the first enzyme called PHGDH, and then the second enzyme is PSAT, and eventually you get to serine. But serine is also very important because it is the starting block for sphingolipids, but also is involved in glutathione production and purine synthesis through the folate pathway. And so when we look at PHGDH1, we can see that it's much higher expressed in tumor-bearing animals fed with high-fat diet compared to animals that have tumors but are fed a normal diet. The same is for PSAT1, but not necessarily for those enzymes. So currently we're studying this pathway further, and most importantly, we want to know from these three outcomes, sphingolipids, glutathione, purine synthesis, which one is actually the most important one in terms of the tumors induced by high-fat diet. And then we have identified a gene that is quite interesting. It's called TSPAN8, and it's a cancer gene with multiple function. So TSPAN8 is this green molecule here at the plasma membrane. So it's a membrane protein that actually interacts with cholesterol. That's also something that we find very interesting. But then it gets internalized, and it can also enter the nucleus and drive transcription together with STAT3 and drive oncogenic genes. As well, there's a number of different transcription factors that drive the expression of genes, of TSPAN8. So when we look at the expression of TSPAN8 in high-fat diet-fed animal, it's a lot higher than in tumor-bearing animals fed with chow diet, and also in the obese mice, which are obese, we see much higher levels of expression. We also have done that with qPCR. So this is the previous experiment was with RNA sequencing. This is qPCR. Now you can see here when you control animals that have no tumors, in high-fat diets, they actually have higher expression of TSPAN8, but when they have tumors, now the expression is much higher. And interestingly enough, TSPAN8 is part of a larger gene family called the tetraspanins. You can see them all here, but it's only TSPAN8 that is really changed expression compared to the others. So it's quite specific. Now I have to introduce you to a marker called alpha-fetoprotein, which is a known liver tumor marker. And so here we have tumors from animals on chow diet and tumors from animals that were fed high-fat diet. And by monitoring AFP with an ELISA, we can see an increase. So they have probably more tumors. And we can also do immunofluorescence. So these AFP is only detected where there's a tumor. So now we want to know what happens when we overexpress TSPAN8. So we do the same experiment that we've done before, but we also elevate the levels of TSPAN8 right from the beginning, and we repeat the same experiment that we have done before to get liver tumors. And what we found is that when we add TSPAN8 here, there's at least some animals that have more tumors compared to those that do not express TSPAN8 endogenously. Also, when we look for AFP for tumor counts, these animals have higher AFP levels, so they mean they have more tumors. And we also see that the expression of TSPAN8 on mRNA level is increased when we overexpress TSPAN8. Now, TSPAN8 is an interesting protein because in the normal liver, it's located and can be seen in cholangiocytes. So CK19, cytokeratin 19, only labels cholangiocytes, shown here. And TSPAN8 is actually at the same place. But it's not expressed in hepatocytes in the normal liver. Now we looked in the tumors, and in our tumors we also have a GFP marker, so we know where the tumor is, and this is shown here in green. So these are tumors that you see here, and this would be normal tissue. Now when we stain for TSPAN8, we see very similar patterns than GFP in many cases. So here you can see the merge between TSPAN8 and GFP. It's shown very nicely. But here, in this case, actually, we have TSPAN8 expression, but not so much GFP expressed. So in summary, TSPAN8 is expressed specifically in liver tumors, whereas in the normal liver, it's only expressed in cholangiocytes. Increasing TSPAN levels leads to more tumors. And also, I haven't shown it as in details, just a little bit, but TSPAN8 seems to be induced by high-fat diet. So it's all quite interesting. And so now we're trying to address what happens when we knock out TSPAN8. Do the liver tumors still form? And also, we are working hard to figure out what are the functions of TSPAN8 in HCC. So in summary, what I've shown you is that the liver plays an important role in cardiometabolic diseases and in liver cancer, but it's of course not the only important organ. I also showed you that the inter-organ crosstalk needs to be more studied, and TSPAN8 is involved in the obesity-induced HCC. And at the same time, we're also validating other targets of HCC. So with that, I would end my talk and thank all the members from my lab, as well as, of course, Karina, who was there in the summer, and our collaborators. Without them, we couldn't actually do our work. So with that, I am happy to take any questions.
First of all, thank you so much for your presentation. We are so glad to see you today, and even with the small problems, we did it today together. And maybe I have one question. Considering to the that high-calorie diet can and obesity in general can promote liver fibrosis and even development of hepatocellular carcinoma. How do you view to the role of ketogenic diets, which are now so popular? In that context, science they may improve insulin sensitivity, but at the same time increase lipid accumulation in the liver.
Yeah, so we haven't tried that ourselves in our mouse models, but there was just a recent report actually that these ketogenic diets may also have negative effects because it can also lead to degradation of proteins and other things that may not, in the long term, may not be so positive actually as people have thought at the beginning. Of course, I mean, reducing fat intake is always going to be a primary goal in this context. But at the same time, we also need to understand that in many cases, those people that are really obese, it's not they. We know now they have a problem in their brain actually, and that may not be able to be changed just by diet. So, and they do need help. And nowadays, I mean, the most promising are these GLP agonists drugs like Wegovy and others, Ozempic, and they seem to work very well. But in terms of the liver, it's still not really clear if this is going to be a solution.
Okay, thank you so much for your answer. Maybe more questions? Yes.
For your presentation. Slides you represent that this T-span 8, if we knock it out or decrease it, we still don't know if it will affect the tumors. But my question comes on the factor TGF beta. If we decrease or inhibit that, will it decrease the chances of fibrosis?
And that's a very good question, and I think that you're correct with that. So if we inhibit TGF beta, we probably will decrease fibrosis. The problem is that the TGF beta has so many functions in the cell that this could be quite toxic. And so that's we have to figure out downstream of TGF beta to get higher specificity. But I think in general, if we can dampen the signal from TGF beta under these conditions without causing too many side effects, that's a very good approach.
Thank you, sir.
Thank you. More questions? No? Then thank you so much for your time. Thank you so much for your presentation. And we were so glad to see you.
Thank you. Thank you. Have a nice day.
Thank you. Have a nice day
Bye-bye.
too. Bye-bye.
Bye. Bye.
А зараз ми б хотіли оголосити подальший план для нашої конференції. І як ви розумієте, ми трішки відхилилися від наших таймінгів, і половину учасників вже пішли на воркшопи. Ми розуміємо, що зараз в теорії з 12:00 до 13:00 відбувається обідня перерва. З 13:30 до 15:30 відбуваються хірургічні воркшопи. Ваші координатори воркшопів мали повідомити вас, якщо якісь зміни були проведені і час інший. Також з 16:00 до 17:00 проводитимуться дебати. Дуже просимо вас всіх бути тут, буде дуже цікаво. А також з 18:30 та 19:30 наша соцпрограма Living Workshop.
So, dear participants, now we are having lunch break up to the 1 p.m. Then from 1:30 to 3:30 p.m. we are having surgical workshops. If there were any changes, your coordinators have chatted you in your chat. Then from 16 to 17, from 4 to 5 p.m. we are having debates here in this hall, so we are waiting for you. And from 6:30 to 7:30 we are having activities.
А також, якщо у вас виникнуть будь-які запитання, ви можете в будь-який момент написати у чат учасників або скоординуватися з координаторами воркшопів, де ви маєте бути. Тому продуктивного дня разом з Medsynergy.
So if you have any questions, you can ask your coordinators or any member of the organizing team, and have a productive day on the Medsynergy day.